Okay, on his slide 25, Chris Monckton talks about the 2,500 IPCC scientists lie. And then he talks about 4 scientific papers related to IPCC climate sensitivity. So there's a bit of a confusion. Is he talking about scientists or papers? And I'll frame my response dealing with both. And in fact, here he references the CO2 forcing coefficient, Planck parameter, and feedback multiplier. So let's investigate. Just to recap, Christopher Monckton seems to be confusing scientists with references. He stated that the number of authors was 50 and that more reviewers rejected the IPCC than wrote it. And that would be incredible if it were true. So what I want to do is start looking at the amount of data which went into construction of the IPCC report. So if you take a number of references in a single chapter of a single part of the report, 275 references just in Chapter 1 of Working Group 1. And there are 43 chapters in total. So you can see that the amount of references in this document is really incredibly large. And I've got the link here so you can go see for yourself. And just put in this URL and you can actually get the IPCC reports in a PDF file format. But let's continue on. Now, Chris Monckton did talk about climate sensitivity, so let's just look into this issue. If you look at Chapter 10, which deals not exclusively with climate sensitivity, and by the way, that's Chapter 10 of Working Group 1, but it's a chapter which has a lot of information about climate sensitivity. You can count the number of papers which deal with that, and I'm not going to count all of them. I'm going to go alphabetically, and here are papers which deal with climate sensitivity. And in many of these cases, the climate sensitivity is mentioned right in the title. For example, in the Andronova paper, and in the Anand paper, and in the Bohr paper, you can see that climate sensitivity is mentioned directly. And continuing on, here are another 5 papers from that chapter which deal with climate sensitivity. By the way, if you see the letters PDF, that stands for probability density function. And here are another 5 papers which dealt with climate sensitivity. And remember, all of these are coming out of a single chapter of the IPCC. And here are another 4. And again, this isn't an exhaustive list. I only went up through M, and there may be papers that I didn't catch. But just looking at the titles, these are the ones I thought dealt with climate sensitivity. I ordered them. I can do that through my library at the university. And I did conclude that these dealt with climate sensitivity. The number, of course, would be far higher than this because it wasn't an exhaustive list, but certainly more than 4 papers deal with climate sensitivity, which is the suggestion which Chris Monckton made on his talk. So in his slide 31, Chris Monckton is onto a new topic, and he's showing that temperatures rise or fall in a chaotic manner, and if you look at different time scales, you can have rises or falls. And well, I'd agree with him. I mean, what you want to do is you want to look at long-term, what are called time-averaged trends. You don't want to look at the temperature this year or that year. Now, Chris Monckton references his work to the Science and Public Policy Organization, which is the organization he worked for. In my mind, a proper citation would be to the originators of the data. In my mind, it is not proper to reference your own organization when they did not collect the data. But what we see here is that if you look at timescales of very short periods, temperatures can rise or fall. So why is this important? So just reiterating on slide 31, he talked about short timescales. Now I'm showing long timescale data, and this is from NASA. I've gotten the link here. It's the Goddard Institute, GISS. You can access this graph. What you see is this temperature data these are annual temperature results going back to 1880. The red curve is a 5-year mean. Now the black squares are actual year-by-year temperature, what are called anomalies. And, you know, every year it goes up or down, up or down, up or down, but there's a long-term trend. And the long-term trend is for rising temperatures. And that's why you want to use time-averaged temperatures over a long period of time. That's why you don't just pick temperature ranges of a few months or a few years. Now, on slide 32, Christopher Monckton disparaged the IPCC head as a railroad engineer without environmental or climate experience. And I did a search on February 2nd, 2010 using a search engine called Scopus, and revealed that Rajendra Pachauri has published at least 41 articles. And here are some of the journals he's published in. Now, I ran out of room. I'm not reproducing all of them, but certainly this guy's got a lot of environmental experience. And certainly he's qualified to speak on this issue, this very, very important issue of climate change. And I don't think his background and expertise should be disparaged. Okay, next on slide 37, Chris Monckton does a comparison of what are called IPCC projections and actual temperature measurements. And what I want you to notice is he's got some data here, again, reference to the Science and Public Policy Organization. In my mind, an improper reference. He says his data was taken from 4 independent sources. Well, that's great, but you got to tell us the sources. You can't just say I got data from sources. Tell us who they are so other people can go in and reconstruct the information. What's the point he's trying to make here? The point he's trying to make is IPCC presents projections that greatly exceed the temperature variation over the last few years. Anyway, I did talk about the importance of not using short time scales, but I'm going to talk about this difference between the ICC and temperature projections in the next few slides. And in fact, on the next slide, Chris Monckton shows something very similar. This time he references, the screen image is very similar to the Science and Public Policy Institute, so you'd expect that they are the ones who originate the data. But he does mention the NCDC monthly temperature anomalies, 2002 to 2008. So again, though, he's trying to make the point that IPCC shows temperature rising and the actual temperature is going down. So let's take a retrospective view on the 2 previous slides from Chris Monckton's presentation, slide 37 and 38. He showed 2 trend lines of IPCC temperatures. And how do those match up? Are the IPCC predictions wrong? Are they too high? And he stated when he produced his graph was taken from the Science and Public Policy Institute, and he's a member of that organization. We don't know if he created the graph or not, but if we take him at his face value, he did produce it. And the first graph showed the IPCC projections of temperature rise of 0.3 degrees in 8 years, or almost 0.35 degrees per decade. But it turns out the IPCC summary for policymakers states the temperature increase is only 0.2 degrees per decade. So there's some disjointedness here. There's some discontinuity between what Monckton says and what the IPCC says. Slide 38 turns out to be worse. Monckton reports a 0.25 degrees Celsius rise in 6 years, or 0.42 degrees per decade. So not only are his results higher than the IPCC, but they don't agree with themselves. But let's continue on and let's see where other disagreements lie. And let's look at the other components of the graphs and see how well they reflect the information from the most up-to-date sources. All right, earlier I talked about the importance of taking time-averaged long time period data. And if you take a very short time period, you can get temperatures that rise or fall. So let's see what the NCDC says about temperature data, because Chris Monckton referenced them. Here's the link. You can get their temperature information, and if you go there, here's their data back to 1880. And what you see here are annual temperature variations in the red bars, and blue is the time average curve. So when you look at it on this scale, hey, temperature is rising, and it's rising pretty dramatically. It's a different inference that you're getting here from that Chris Monckton suggests by looking at very short time periods. Now, if you go to the NCDC's website, and I've got the link here, you can get actual monthly temperature data. And here is the temperature anomaly for the time period 2001 to the present time. And what I want you to notice is you see this curve, and it's jumpy. And this is a curve that's very similar to Chris Monckton's slide 38. There is a bit of a difference, though. It seems like Chris Monckton has moved his curve downwards about 0.2 of a degree Celsius. And if you'll just notice that around month number 1527, temperature anomalies in excess of 0.8 are seen. We'll go back to his slide and show that his are actually a bit lower. His are in the 0.6 to 0.7 range. But this is the data taken directly from their website, and it's available for everyone to access. Now, let's take a longer term view, though. This data goes back to 1880. And what you see is that there's a up and down monthly jiggle. Now what Chris Monckton has done is he's focused just on the part in the upper right. I'm showing that region in a circle. He's saying, you know, temperatures over the last few years haven't gone up, so therefore temperatures aren't really increasing. But that's not really true when you look at the long-term temperature data, and in fact I showed the yearly temperature data from the NCDC a couple slides ago. You see that there's a consistent increase. Okay, so does Chris Monckton agree with himself? We've shown his estimates from the IPCC are wrong, and we've shown that he's really focusing on a short time period, and so his presentation of NCDC data gives the wrong impression. But does he agree with himself? So let's take a side-by-side or top and down view of his slides, and I've got slide 37 and 38 shown here. Now again, the top slide was referenced to the Science and Public Policy Organization. The bottom slide is used with the same kind of font and graph style. It's referenced to the NCDC. And Chris did not say where he got his temperature information for the top slide, but he did mention that it was from 4 sets of data, 4 temperature reconstructions. So there could be some slight differences in temperature information, but at least he should clearly indicate where his temperature data is from. And let's see what happens. You get temperature data that disagree with each other. In the top curve and the bottom curve, the temperature peaks are slightly different. He's got 2 decreases in the bottom, 1 in the top. He's got, again, 2 decreases in the bottom, 1 in the top. He's got a lower decrease and an increase in temperatures in the bottom or top, and then missing a peak. So while there certainly could be differences on your data based on who you're taking your temperature information from, that's understandable. But if you don't tell people where your data is from and you leave it up to them to guess, and then you show 2 slides that look very, very similar, you really leave people guessing as to how you're gathering your information.